In question 1 part A, you have division, so you'll need to subtract the two powers. This will give you e to the power of 6. In part B, expanding will give you x squared minus 3x plus x minus 3. And if you simplify, you get x squared minus 2x minus 3. In question 2, I'm going to use Pythagoras theorem. So 52 squared equals h squared plus 30 squared. So h squared is equal to 52 squared minus 30 squared. H squared is 1804. So h is the square root of this number. As a decimal, that's 42.5 to 3 significant figures. For part A of question 3, just multiply 54 by 4 over 9. This will give you 24. For part B, we have increased the number of white fish by x. So we have 24 plus x white fish, and the total also increased by x. So we've got 54 plus x in total. So this as a probability is equal to 1 over 2 according to the question. So all we have to do now is solve this equation. I'll do so by cross multiplying. So 48 plus 2x equals 54 plus x. So I'm going to take the x to the left, the 48 to the right. X is equal to 6, and this is the final answer. For question 4, note that the 0.5 is the diameter of that window, semicircular window. Hence, the radius is half of that, that's 0.25 meters. The area for the circle is pi r squared. I have half of that. So let's work out the area of the door. That's the area of the rectangle. 2 times 0.75 minus half a circle, so half of pi r squared. This comes out to be 1.401 ... I'm going to keep everything on the calculator. That's meters squared. So the area to varnish is 2 times that one, because we're being told that he will apply 2 coats. So if I do this multiplication, I'm going to get 2.803 and so on meters squared. And I know that to cover 4 meters squared of wood, I need 250 ml of varnish. So for 2.803 and so on, I will need X amount. So to find X, I will just cross multiply. That's 2.803 times 250 over 4. Note I'm using all digits from my calculator. This comes out to be 175 milliliters to the nearest integer. In question 5, I need to find the length and the width of this rectangle. Now, note, because I have 2 unknowns, L and W, I'll need to create 2 equations and solve them simultaneously. The first equation comes from the fact that A in B and C in D are equal. Now, A in B is equal to 5 widths, while C in D is equal to 4 lengths. Hence, the first equation comes from the fact that 5W equals to 4 times L. Now, the second equation will come from the area. Now the whole area is 1620. So the area of one tile is this number divided by 9. And because I know the dimensions of one tile, I can create my second equation, which will be L times W equals to 180. So here are my two equations. I'm going to use substitution. For the first equation, I'm going to get W on its own. So that's 4L over 5. And then I will substitute this into the second equation. So L times 4L over 5 is equal to 180. Expanding will give me 4L squared over 5 is equal to 180. L squared will be 180 divided by 4 over 5. This gives me 225. So L is the square root of this number, which is 15. And finally, W is equal to 4/5 of 15. So W comes out to be 12. For question 6, I'll need to create two simultaneous equations and solve them. I will let A be the cost of an apple and P the cost of a pear. So 5A plus 3P is equal to 1.96. 3A plus 2P is equal to 1.22. I'll multiply the first equation by 2, the second one by 3. So the pairs will be the same. So 10A plus 6P equals 3.92. And 9A plus 6P equals to 3.66. Since I have 6 P's on both equations, I will subtract, so they cancel out. A equals to 0.26. And then I'm going to use the first equation, 5 times 0.26 plus 3P equals to 1.96. So 3P is 0.66. P is 0.22. And now I have the price for each apple and pear. So 10A plus 10P is equal to 10 times 0.26 plus 10 times 0.22, and this gives me 4.80. For question 7, I'll write 3.6 times 10 to the 3 as 3,600, and then I'll go with successive divisions by prime numbers. So divide by 2, 1,800, divide by 2, 900, 2 again, 450, 2 again, 225, then divide by 3, 75, divide by 5, you get 15, divide by 3, you get 5, and finally when you divide by 5, you get 1. So I've got 4 2's, that's 2 to the power of 4, times 3 to the power of 2, times 5 to the power of 2. Note the order in which you make the divisions is not important. Now, alternatively, I can write this number as 36 times 10 to the power of 2, which is 36 times 100, and I can find 36 and 100 as powers of prime numbers. 36 can be divided by 2, 18 by 2, 9, 3 will give me 3, then 3 will give me 1, and 100 will be divided by 2, will give me 50, by 2 again will give me 25, 5, 5, and then 5, 1. Now if you look at both columns of prime numbers, you will see that I have 4 2's, 2 3s and 2 5s, and these are the powers of the prime factors. In question 8, I'm given that Sydney is equal to 22% of Australia, and I'm given that Sydney is 5.48 million. So I've got 5.48 equals 0.22 times Australia. So Australia is equal to 5.48 divided by 0.22, which comes out to be 24.9 million. For part I of question 9, I'll split this into two inequalities, the blue and the red. Now for the blue one, minus 7 less than or equal 2x minus 3. So minus 4 less than or equal to 2x. So minus 2 is less than or equal to x. And then for the red one, I've got 2x minus 3 less than 5. So 2x is less than 8. X is less than 4. So if I join this, I'm going to have x between minus 2 and 4, minus 2 being included. For part II, I need to put this answer on a number line. Now at minus 2, I will have a full circle because that value is included. At 4, I will have an open circle, and I will take the ruler and join this with a straight line. In question 10, I have a density mass volume question. Now the formula states that density equals mass over volume. If I rearrange this equation, I will get volume equals to mass over density. So 5.4 divided by 0.0027 will give me 2,000, and those are cubic centimeters. Now the formula for the volume of a cylinder is the following. So 2000 equals to pi times 10 squared times h, which means that h is equal to 2000 divided by 100 pi. If you put this on the calculator, you will get 6.421 decimal place. For part A of question 11, I'll just add the frequencies to create the cumulative frequency column. So the first one is 12, the second one is 12 and 24, which is 36. The next one will be 12, 24, and 28, which will be 64, and so on. So I get 76, 86, and finally 90. For part B, I need to plot these on the graph. Now the coordinates will be the following. This column are the x coordinates, this column are the y coordinates, and because everything starts from 25, I will cut my horizontal axis at 25. So 25, 0 will be my starting point. So let's plot the points. And now you can join this with a smooth curve or using your ruler and creating line segments like I will do now. Now for part B, I need to find the estimate for the number of runners who are awarded a silver medal, and those are the ones that had a time between 42 and 52. So let's go to the graph. I'll start from the horizontal axis at 42 and 52, and then go up and then left to read off the cumulative frequency. Now on the x-axis, That's my 42, that's the 52. And then on the y-axis, I will get a 28 here and a 55 for the second one, which means that 55 minus 28, which is 27, is my final answer. Note, the mark scheme accepts answers between 25 and 29. In part of question 12, I'm going to use right angle triangle trigonometry because I have this right angle triangle. I know the opposite and the adjacent, so I'm going to use tan. So tan of 20 equals to 100 divided by d. So d is equal to 100 over tan of 20. This is 274.74 and so on. To three significant figures, this is 275. For part B, I will work with another right angle triangle. The angle of elevation of A from B, which is this one, that's 25 degrees. I need to find the height of the radio mast, which is this one. And to do so, I will first find the vertical height of this triangle and subtract 100. So using the red triangle, I can use right angle trigonometry again. So tan of 25 equals opposite over the adjacent. Now I have this stored in the calculator. It's the last calculation I did. So x equals this number times tan of 25. X comes out to be 128.11 and so on. So the height is 128.11 and so on, minus 100, and this will give me 28.1 meters, and that's the height of the radio mast. Now question 13 is a bit tricky, and I'll show you in a while why this is the case. Now first, I'll start by labeling my sides. This is side X, this is side Y, and this is side Z. So X, Y, and Z. Next, I'll find the lower and upper values for 16, 130, and 25. So for Y, this is between 15.5 and 16.5. Angle X is between 125 and 135, and angle Y is between 24.5 and 25.5. To find length YZ, which is X, I'll need to use the sine rule. So X over sine of X equals to Y over sine of Y. And if I rearrange, I'll get X equals to Y times sine of X over sine of Y. Now I need the upper bound for that, which means I need the upper bound of the numerator and the lower bound of the denominator. And in the numerator, I have a product, so I need the upper bound of both terms. So let's continue on the sides. 16.5, which is the upper bound of Y. Here it is. Times the upper bound for sine X, and then divided by the lower bound of sine Y. Now the intuitive thing to do is for the upper bound of sine x to take the largest value of angle x, but this is wrong because sine function is not one-to-one function. Let's have a look at the sine function. That's how the graph looks like. Now I'm in a triangle, so I can have angles bigger than 180, so forget about this part of the graph. Just focus between 0 and 180. Note the maximum value happens when x is 90 degrees. So the closer I am to 90 degrees, the bigger the value of sine x. If I move further away from 90, my graph gets closer to 0. So to get an upper bound for sine x, I need an angle of x that is as close as possible to 90 degrees, and out of the two extremes, 125 is closer to 90 degrees. Let's write this down, sine of 125. And for the denominator, I need the lower bound of sine y, which means my y value should be as far away from 90 as possible. And out of those two values, the one that is further away from 90 is 24.5, hence sine of 24.5. If you put this on the calculator, you will get 32.6 to 1 decimal place. For question 14, I'll start by dividing the hexagons into equilateral triangles. Now, because the scale factor is 2, this means that each side of the big one is twice the side of the small one. So let's start with part I. I need to find A and B. To go from A to B, I will go A backwards and B forwards, which means that I've got minus A plus B. Then Ki, which is from here to here, this will basically travel from K to J. This is twice A and B, and then I'll go from J to I, which is twice B. So let's write this down. Ki is the same as going from K to J, and then from J to I. Kj is twice minus A plus B, and Ji is 2b. Let's expand, minus 2A plus 2b plus 2b, which is minus 2A plus 4b. And then for I need LD. This is L, this is D. So I will go horizontally from L to D. This is twice A and B, same as before. And then I'm going to travel from O to D, which is the same as going A backwards. So LD is equal to LO plus OD, and then LO is 2 times minus A plus B. OD is the same as going A backwards, so it's minus A. So let's expand, minus 2A plus 2B minus A, which gives me minus 3A plus 2B. For part B, we are given the triangle OAB. That's one of the small triangles, has an area of 5 cm squared. So the area of the small hexagon is equal to 6 times 5, which is 30. And then I'm going to work with similar shapes. So I'm going to create the following table. For the length, the scale factor is equal to 2. I'm being told that in the question. Hence, for the area, the scale factor is 2 squared, which means if I have an area of 30 for the small one, the area of the large one is 120. So the shaded area is equal to 120 minus 30, which is equal to 90 cm squared. For question 15, let's start by completing this probability. Now the sum of these three probabilities should be 1, so the missing one is 3/9, and because the games are independent, it means that these three will be exactly as these three. Let's write them down: 2/9, 4/9, and 3/9, and then the others will be exactly the same. For part B, I want the probability that after 2 games they have the same number of points. So this is the probability MG, where M is the event that Magnus wins and G is the event that Gary wins, plus the probability of the other way around, so GM plus the probability of getting a draw twice. Now probability MG will be the product of this number and this number. Then the probability GM will be this one times this one, and then I have the draw, which is the product of this. So let's write this down. I've got 2/9 times 3/9 plus 3/9 times 2/9 plus 4/9 times itself. You put this on the calculator, you will get 28/81. Now for part C, we have a third game with the same probabilities, and we want to have a draw after 3 games. Now to have a draw after 3 games, we need the probability M, G, and D, but I want any combination of these 3 letters, and I also want the combination where I have 3 draws. Now for these 6 combinations, I will have 2/9 times 3/9 times 4/9. The 2 is for Magnum winning, the 3 is for Gary winning, and the 4 is for a draw. And all the rest will be exactly the same. It's just the numerators will be reshuffled. So I have this number times 6 combinations, and then for the last one, that's 4/9 times 4/9 times 4/9, and then I'm gonna add these 2 results. The first combination gives 16/81, that's for all 6 of them, and the second one gives 64/729, and if you add these 2 numbers, you get 208/729, which is the final answer. For question 16, I'll start from the end of this list. So I've got X students passed all 3 tests, so the middle region is X. 4 students failed all 3 tests, so that's the outside region, that's 4. And then 11 students passed the test in maths and French, so these 2 regions are 11, so the left part is 11 minus X. Similarly, 18 students passed in maths and English, so these 2 regions are 18, so the top one is 18 minus X. I have 14 students that passed the French test, so the whole circle of French is 14. I've got 11 here and another 213. So there's only one in only French. And then I have 20 for English. These two regions are 18 plus another 2, that's 20. So there's 0 in here where the only English is. And then I have 25 in maths. So this will be my equation to solve for x. So using maths, I have 3 plus 18 minus x plus x plus 11 minus x. So these are these 4 regions, and this is equal to 25. So 32 minus x is 25. X comes out to be 7. Now on the next page, I'm asked to complete the Venn diagram with the x I found. So this region is 18 minus 7, which is 11. The middle region is x, which is 7. This one is 11 minus x, so 11 minus 7, which is 4. The bottom one is 1 anyway. That's 0 and 4. And then for part C, a student who passed the test in math is chosen at random. So we select one of the 25 people who passed the test in maths. And out of those 25, I want the probability that a student failed in French. So I don't want them to be in French. I want one of those 14 people. So the answer will be 14 out of 25. For part of question 17, the two factors will be y minus 1 and 6y plus 5. Then for part B, I will cross multiply. So 8w minus fw equals 2f plus 3. So 8w minus 3 equals 2f plus fw. I'll rewrite the left-hand side, and on the right, I'll take f as a common factor. 2 plus w is what is left. So f is equal to 8w minus 3 divided by 2 plus w. In part C, I'll need to complete the square. I'll start by taking 4 as a common factor from the first two terms. So that's 4 square bracket x squared minus 2x, close the square bracket, plus 7. And then I'll focus on this one, come to the side and complete the square. X squared minus 2x equals to x minus 1 squared minus 1 squared, which is x minus 1 squared minus 1. So coming back to the previous step, that's 4 square bracket x minus 1 squared minus 1 plus 7. Expand the square brackets. So 4 x minus 1 squared minus 4 plus 7. I'm only expanding the square bracket, not the other bracket. That's the whole purpose of the question. Also note, many students forget to close the square bracket. So when they expand, they only do this expansion and forget about the 4 times minus 1. And then I'm going to simplify and get my final answer, which is 4x minus 1 squared plus 3. Question 18 is a very tricky question. Let's start by actually explaining what this means. So if I let y equals 0.4x with a dot, that is 0.4x, and so on. But x here is not multiplied to 0.4. X is a digit that appears on the second, third, fourth, and so on decimal places. So this is actually 4 times 0.1 plus x times 0.01 plus x times 0.001 and so on, where 0.1, 0.01, 0.001 are the values of each decimal place. Now, let's start by noting that the first x appears here and ends here. So relative to the dot, to the decimal place, that's one place after it and stops two places after the dot. So I'm going to have here 100y is equal to 4x dot xx and so on, while 10y is equal to 4 dot xx dot dot dot, and then I can subtract those two and get 90y, 4x minus 4, and everything after the dot cancels out. Now again, this 4x is not 4 times x, this is 40 plus an extra x, so 90y is equal to 40 plus x minus 4, so 90y is 36 plus x, which means y is 36 plus x divided by 90, and that is my final answer. In question 19, the triangle I'm given is equilateral, so all angles are 60 degrees and all sides are equal. This is x because this is an x, and then the other two are equal to the base. And I need to find the area. Now the area of the triangle is given by the following formula. So the total area is xy, that's the area of the rectangle, plus 1 over 2 x times sine of 60. So r is equal to xy plus a half x squared times square root of 3 over 2 for sine 60. If I simplify, that's xy plus square root of 3 over 4 times x squared. Now the answer I have to show doesn't have any y, and to replace y with some expression I need to work out with the perimeter, and the perimeter of this shape is equal to 1, 2, 3 x's and 2 y's. So that's 3x plus 2y. Now I'm given that the perimeter is 100, so 100 is equal to 3x plus 2y, and if I rearrange, 100 minus 3x equals 2y, so y is equal to 100 minus 3x over 2. So now I'm going to replace y with this expression here. So r is equal to x times 100 minus 3x over 2 plus square root of 3 over 4 x squared. Let's expand the bracket. So r equals to 100x over 2 minus 3x squared over 2 plus square root of 3 over 4 x squared. So r is equal to, and I'm going to make all the denominators now to be equal to 4. So I'm going to have 4 here. So I'm going to multiply the first one by 2. So that's 200x minus 6x squared plus square root of 3x squared. And then I'm going to take out a common factor of x and 1 over 4. So now I'll be left with 200 minus 6x plus square root of 3 times x. And finally, this is equal to x over 4, and then a big bracket, 200 minus, and from the last two terms, I'm going to take out a factor of minus at the front and x after the bracket, which will give me 6 minus square root of 3x as required. Now in part BI, I need to find the value of x for which r has a maximum value. To find this, I will first differentiate and set to 0. Now of all the versions of r I have here, this one is the best one to use. This simplifies to 50x minus 3 over 2x squared plus square root of 3 over 4x squared. So dr dx gives me 50 minus 3x plus square root of 3 over 2x. And now I'm going to set this equal to 0. So 50 equals to 3x minus square root of 3 over 2x. Gonna remove the fraction by multiplying everything by 2. So 100 equals to 6x minus square root of 3x. So 100 equals, take out the common factor of x, 6 minus square root of 3. So finally, divide by the bracket, so 100 over 6 minus square root of 3. No need to rationalize, I am asked to give it in this form, which I just did. Now for the second part of B, explain why the maximum value of r is given by this value of x. Many ways to do this. I will differentiate for a second time, so d2r dx squared is equal to minus 3 plus square root of 3 over 2. This is approximately minus 2.13, which is less than 0. So let's just rewrite this. Less than 0, hence maximum. Now, alternatively for this mark, you can just say that r is a quadratic with a negative coefficient of x squared, hence there is a maximum. For question 20, I've got line L passing through these 2 points. Now, point B is to the right of point A, and point B is above point A. So it has a positive gradient. That's how the line looks like. Let's put the 2 points on. Now, line M is perpendicular to L and passes through the midpoint of A and B. So line M looks like this. Now, throughout this problem, I will make use of the following formulae or rules. The gradient of line L is equal to 3 minus 2 over 5 minus 6, which is 1 over 11. I just make use of this formula. So the gradient of line M, which is perpendicular, according to this formula, is minus 1 over 11, which is basically 11. I'll also need the midpoint of AB, and according to this formula, this will be minus 6 plus 5 over 2, comma 2 plus 3 over 2. This comes out to be minus 1 over 2, 5 over 2. I will call this point D. So that's D. Now the point C I'm trying to find is on line M when x is minus 1. So C should be somewhere here. So let's put a C there. So the line M can be found by using y equals mx plus c. 5 over 2 equals minus 11 times minus 1 over 2 plus c. So c comes out to be minus 3. Hence, the equation of this line is y equals minus 11x minus 3. So point C can be found by setting x equals minus 1 on this line. Hence, y equals minus 11 times minus 1 minus 3, which is equal to 8. So point C is minus 1, 8. So to find the area of triangle ABC, let's first construct this triangle. Now the height of this triangle is sin D and the base is A and B. I know all the points, so I can use this formula twice to find base and height. So let's do so. Sin D is equal to minus 1 minus a half, so that's plus a half squared plus 8 minus 5 over 2 squared, and let's take the square root of that. That is equal to square root of 122 over 2, and then A and B equals 5 minus 6, so plus 6 squared plus 3 minus 2 squared. Square root of that is the square root of 122. So area is equal to base times height over 2. So 122 over 2 times root of 122 divided by 2. And this will give me an answer of 30.5.